Sorry for the delay. A little last-minute configuration changes here. Thank you guys for coming to this session. I know it's probably been a long Dreamforce for you guys. It's been a long one for me. But how was Dreamforce this year? Pretty good? Great. That's what we like to hear. We're always very concerned that you get what you need when you come to this event. So glad to hear that you guys are doing well. So today, what we're going to talk about is choosing the right technology for your solution on the platform. Over the years, the platform has grown significantly. There's a number of different ways that you can do things, and we've got a couple of Force.com ninjas here to give you some of their experience, some of the things that they've done, things that they've come up against, and how they've chosen which way to go to solve their problems. And so without further ado, I'd like to introduce, well, wait, before I do that, right, okay, safe harbor statement. Read that on /investor, salesforce.com. So Jeff Douglas from Aperio. Come on up, Jeff.
Thanks, Dave.
Thank you.
Good morning. Glad you guys could make it today. You know this is the Dev 501 certification exam, right? Everybody knows that? Okay. Well, this is me from Aperio, and this is our obligatory marketing slide. Has anybody here not heard of Aperio? Awesome. Tell me they did a good job. Well, so I'll just do this real quickly. So in about 30 seconds are left. Aperio is a cloud source company. We actually provide product and services that help enterprises move their business to the cloud. And we've been pretty successful so far. We've got 3 of the top 10 App Exchange apps. We grew about 300% last year. And we were really the first company to partner with both Salesforce and Google. And we work with some of their most innovative and largest customers like Japan Post, Starbucks, Avon, and Thomson Reuters. So we're going to go over 2 cases that we use, one when I was at another company and then one here at Aperio, and talk about some of the issues we had to come up with and some of the solutions that we used for the final implementation. So the first one is for Informer PLC. They're actually based out of London, and they're an international provider of specialty information services, and they've got about 2,000 users on the platform and about 20 different countries. And I was a developer there for a couple years. And I was working on an application with one of their internal companies, and it involved, identifying new book sales opportunities, actually delivering professors inspection copies of books, and then doing the follow-up on these books. But the problem was the feedback they were getting was either they're going to buy the book for themselves, or they were going to return the book, or they were going to adapt it for their class. They preferred the last one, of course. But the issue was that it was a paper-based process. They would send a feedback form out, and it would come back 6 to 8 weeks later, and they'd enter the details into Salesforce. So I sat in on the keynote last year with Sites, and I said that's the way to do it, with Sites. So we went back and we got on the pre-release pilot for Sites, and I pitched Sites to the business as a way to dramatically reduce the feedback time and cut out the paper-based processes. So the application actually is part of the Sites application is part of a larger application that starts when a book is sent to a professor. And typically it was, paper was sent out for the feedback form, but we wrote workflow that kicked out an email 21 days after the book was marked as shipped. And so what was nice about it, the professor got an email with a link on it. He would click the link, and it would open up in the browser, and you'd see the actual record for the inspection copy, and they would fill out the form with any feedback, strengths and weaknesses, what are you going to do with the book, and stuff like that. So it worked out real well. About the same time, I was working on the Salesforce Google App Engine for Java Toolkit, and I was doing some demos. I was writing some demos for that, and I thought a cool project would be to see if I could port this Sites app to App Engine. And it actually worked pretty well. I got most stuff over there, but in the end, we decided to stay with Sites for a number of reasons. The biggest reason probably was the data model. With App Engine, we had to create our own data model with the POJOs and data access objects. But with Sites, you just take the custom objects and expose them publicly, and then you share the same record both internally and externally. So that was really a no-brainer. Since if we were going to use App Engine, we'd have to write an integration layer, some way to move the data in and out of App Engine and have some kind of scheduling framework. But with Sites, the data is just there. It's in Salesforce, it's in Sites, it's the same data, so there's no need for that. On this project, we didn't use authentication, but it's really simple using the customer portal. And if you look at the trade-off between writing your own authentication framework, maintaining it, providing user I forgot my password functionality and provisioning, then actually the customer portal is a really attractive feature. And my favorite was the validation rules. There's a ton of frameworks for JavaScript that you can use to implement form validation, but it just seemed like double the work. I would make a change to a validation rule in Salesforce, I had to make the same change in App Engine and then retest. Where with Sites, you just set that validation rule up and it fires both internally and externally. So that was no-brainer also. So this is actually the application, and I got it here. I can show you real quick here. So this is what it looks like. The professor clicks on a link, and they see this page immediately, and they can fill out information about what they want to do with the book, provide any information such as competitor information, book strengths and weaknesses, and they submit that, and it goes right back to the rep, and they can follow up on the opportunity. It worked out really well for them, and this is their production org, so I'm not going to submit this. Okay, the next case study is DeVry University, and one of the challenges we find on these larger, more complex projects is how do you actually orchestrate long-running processes that actually initiate and complete on the Force.com platform? So, everybody's worked with governor limits, and I'm not sure everybody loves governor limits, but that's actually one of the features that makes developing on Salesforce as a business and development platform so great. Because you have to write the code that actually makes you so that you run well on the platform, you don't interfere with other people's codes, and you don't hog system resources. So it's really not a big issue once you learn how to work within the framework, but it's actually one of the great things about Salesforce. So on this project, we ran the same kind of things. We were pushing the platform to the limit. We had a lot of complex operations in there, and we were running the governed limits. What we had to actually do is take a step back and look at what is a transaction. How is that constructed, and how is it used? So we had to look at that quite heavily. And then we also use a lot of future methods to do some of the heavy lifting throughout the application. And we developed what we call the heartbeat pattern, where we use an outside system to do processing inside Salesforce. And I'll show some information on that in a second here. So what is a transaction? So the transaction begins when Apex invoked, and it commits automatically when it finishes successfully. But what happens in these long-running processes when you have something like a governor exception, or you have a validation rule that fails, or maybe you're trying to do a call-out when you have a DML process that needs to run? So you're going to get an error, and it's going to roll everything back, and you're going to lose everything. So we had to look at the transaction to get them as small as possible, so they run under 10 seconds. That's when our rule of thumb was to run under 10 seconds, and make them really small. Because we were running into problems with these long-running processes, and you have multiple that run concurrently, we were locking up the server and getting HTTP 503 errors. So our rule of thumb was to make them really small so that it would execute quickly. So one of the best, most efficient ways we did this was using future methods. And these helped us streamline the process and actually make these transactions more manageable. And these are actually static methods that have a future annotation that run asynchronously when the system has resources. And one of the things about them is that you can't guarantee the order of operation. You can't chain them together, so that makes it kind of difficult to work with them. So we did some things to work around that. We ran into some limits, such as there's actually a limit that says you can't call a future method from another future method. And we ran into that quite early. So we found some ways to work around that. And you notice that because you'll see something like, in this example, you'll have a trigger that inserts or updates some records and makes a call to a future method, which then updates some information on the records and then saves it. But that save fires a trigger off again. So you get this circular call to itself. And we had to deal with that quite a bit. So we developed some code to kind of help prevent that, to kick you out of that loop. So what we have is a public class that has a static variable called inFutureContext that's shared by all the triggers that are invoked from that request. So what happens is, on the trigger, it runs before insert and before update. It actually looks at the value of inFutureContext, and if it's set to false, it's going to process all the records in that context. And then it's going to call the future method, which is process accounts, and it's going to pass it off all those records. So in the account processor class, the future method, it actually makes the updates to the records, changes some values, and gets ready to save them back to the database. Right before it does that, it changes the value of inFutureContext to true. So that way when it fires, the update fires, it's going to come back to the trigger again, and it inspects the value of your static variable, and it says, okay, it's true now, and so it kicks you out of that loop. So we use that quite a bit for all that stuff. And so the heartbeat pattern, what's the heartbeat pattern? So this is just a simple explanation of what it is. You may have it triggered, and if you fire off a secrets method, and it does some processing in there. And from some business rules, it throws some records into a temp object. And this temp object is just as a queue to store records. And then you may have an external system that makes calls into that queue and determines that there's records to be processed. So you may do something like you save a number of leads, call a future method that says, okay, are there possible dupes in here? So you may find X number of dupes and throws them into this queue. So then you have this external system which pulls this queue to find out if there are records in there. So it finds the records and it makes web service calls into this queue because you get more governed limit. You can actually query more with governed limits from a web service than you can natively like a controller or class. So we use that a lot for calling back in and actually do processing. But one of the great things about Salesforce, though, is that every 3 months we get new toys, or every 3 times a year we get new toys to play with. So as they release new revisions all the time, we're finding less and less things that we have to run outside the platform. So we're hoping that with the batch and schedule Apex, we can pull this heartbeat pattern out of this external system and put it into Salesforce. Because we typically want to have something like a BizTalk or a Sonic that runs outside that pulls, because it has connectors like Salesforce and databases and SAP and ERP systems and flat files. So we're hoping to replace that with something natively. Everything goes GA. So I actually have this running here too. So this is a little test runner we wrote here, and let me start this up. So this is typically you may have something externally making calls in, but we actually simulate it with JavaScript. So the JavaScript in this page is making recursive calls every 5 minutes or so, or every 5 seconds or so. And I think in Firefox this actually pulses, but I don't think it does in Chrome. So what we do is we're gonna submit a new lead, and if I'm fast enough, I can see at the bottom here that it's catching the lead and pulling every 5 seconds and trying to process that lead. So it's making a couple calls out all the time. So let me generate this lead. So you'll see here, generate the lead, and then if I hit the status, you can see it making changes. So there you go. So it just processed it. So it's quick enough. Thankfully, the platform's fast enough where it makes calls out, comes back, and makes another call out. So it's hard to catch us in here. But if you want to come after, we can explain more of how this is working. And we have the Dr. Jarvik of the heartbeat pattern right in front row, so he'd be happy to explain it. So this is just a little bit of the code of the JavaScript that's in that Visualforce page. He just loads up a jQuery as a resource, and you can see right here, this is the actual method that's calling the heartbeat, and it just keeps calling itself and calling itself and calling itself to simulate that. But typically that would be some kind of external system. That's it. Any questions, or do you want to close to the end? Yes. Yeah, we did that with our PSE product, and if I'm wrong, let me know, but we actually have a unique identifier, and so instead of the whole records in there, we send an ID we use, not a Salesforce ID, but our own ID that's unique. We send that over, and then it queries for that, because, right, you only send simple types over. That's how we were doing it, and I think if you look at the code right here, you can probably see that right here. So we have a unique name we have in there. So we're passing that a string of unique names over there. Because on the insert method, you're not going to have those IDs yet because they won't exist. So this is one way we got around that.
What external system were you hosting the code that actually does the heartbeat?
I think we typically use EC2. We run something on EC2. I know we've done some. We run to Amazon quite a bit. I'm not sure what. I think we had a JBoss system running some stuff like that too. Sir. Yeah, I was bored. Yeah, I had free time between 5 and 7 in the morning, so I was doing app engine stuff. So. And also, I mentioned I actually have a book on App Engine coming out next month. Kyle Roach and I from Imperial have a book on App Engine. So if you're interested, it's at Amazon. Has a lot of Salesforce examples in there with App Engine. Nope. Okay.
You know, this session is meant to be refreshing and give you real-world examples of people solving problems on Salesforce.com and with the Force.com platform. And I think that was a pretty good example of a real-world application where you make some trade-offs and make some choices. One of the really exciting things, as I mentioned, is that Salesforce is continually pushing the envelope on what the platform can do. And next year, maybe we'll have that heartbeat pattern implemented entirely in Salesforce. So
we're hoping.
Yeah. So great. Well, next up is Rick Cummings from IDR Media, and he's an IT architect, obviously, from the title. Great customer of ours, and he's done a lot of cool implementations. So, Rick?
Thank you. I always appreciate the opportunity to speak in front of the huddled masses. And I see some people out there that I've met earlier this week. That guy over there looks like he's sleeping. Oh, okay, sorry. I work for IDR Media. We are the local advertising agency. We like to bill ourselves for small and medium-sized companies. We're headquartered in Dallas, Texas. We have about 6,500 employees, 2,700 media consultants or sales reps. We have around 830,000 clients. We publish over 1,200 printed directories in 34 states in the District of Columbia. We have a pretty significant national internet presence, as well as we support other types of advertising media, such as direct mailing and so forth and so on. Before I get started, I just want to go over the ecosystem that we developed and why we followed this particular design pattern. Up until very recently, we have been operating as two separate businesses under the umbrella of one single business. We had a print selling channel and an electronic selling channel, each focusing on different consumers. Each one of these folks operated within their same legacy applications with an individual CRM. Each had their own CRM, each had their own ERP application supporting that CRM, and each had their own selling process. Part of what we're doing as an enterprise is merging these two selling systems or these two sales channels into one sales channel, merging selling processes and giving them a single selling system. So what we did is we elected Salesforce.com to be our single CRM and went through our legacy applications and identified commonalities between both legacy applications and redeployed those out on Salesforce.com. Our initial objective was to take advantage of sales pipeline management that's available on Salesforce.com and eventually grow off of that into order management and integrating with our ERP system. So as we moved along after implementing pipeline management, we continued to look at our legacy applications, identifying commonalities, merging our selling system or our business processes to support these commonalities and deploying that out on Salesforce.com. And what that left behind was two existing legacy applications that we've rusted away to become pure fulfillment engines. So the common functionality sitting out there on Salesforce.com, our legacy applications redeployed as web servers and exposed to Salesforce.com through a service-oriented architecture, which is governed by our enterprise service bus. Okay, the use cases I'm going to be talking about, one is a workflow application, the implement choices that we made along the way in that application, evolving complexity, how we were able to facilitate flexibility through customization, and how we started off with one track, and as the requirements became too heavy to support too heavy to be supported by that direction, we switched to a more customization approach. And the third use case, which is probably the most interesting part, is the integration strategies that we took while developing this service-oriented architecture and allowing Salesforce.com to communicate with our existing legacy applications. Okay, the workflow application. Our media consultants, all 2,700 of them, plus give or take 300 other account management type people, they're budgeted to make 6 sales per day. This generates up to 70,000 documents per month. All of these documents need to be fed through a workflow approval process. Up until now, this workflow approval process was handled in multiple ways based on the different divisions throughout the company. What we did was took Salesforce.com, utilized its workflow and approval process, and built this workflow functionality up in Salesforce.com. However, the end point of the workflow process is one of our legacy applications. Like I mentioned before, we have a significant investment in our legacy applications, and we are looking for commonalities that can be deployed out in the cloud. But there's some components out there in the legacy ecosystem that we want to keep where it is, and one of them is this document management system. And it's also being used by other people throughout the enterprise, not just for the sales staff. So we have this sales approval process sitting out there in Salesforce.com. At the end of the day, after the approval process is completed, we need to move those documents out of Salesforce over the wire into our internal ecosystem, and then upload them into our enterprise document management system. Now, the choices that we made, first of all, for the workflow component, we of course went with Force.com. And right here I put up a decision we had to make between triggers and workflow. But that was really a no-brainer. I mean, Salesforce.com comes with workflow, it comes with the approval process. So much of our approval process, it's fairly dynamic, so there was some custom coding going on. But one of the primary tenets that we're following throughout our software development lifecycle, when we made this one of our standards early, and just sitting in on all these other sessions, it seems to have become a mantra that you hear over and over the past week, is to configure versus develop. So workflow gave us that ability to configure versus develop, where it's more out-of-the-box functionality. We're clicking instead of coding, even though in this circumstance we did need to do some custom code. So workflow gave us the advantage of it being native functionality within Salesforce.com. It's optimized. It's controlled. We have a lot of control of how we can do it. Triggers, even though I love triggers, and I like to consider myself a pure developer, and I mean one of the most fun I ever had was developing a connection pooling mechanism in a J2EE application. So I could sit and code all day, and if somebody was to say there's a better way to do it, I'd have to go to that crying. But it just makes sense that workflows were much better than triggers in this circumstance. Now, we love our users, especially our sales reps, and we try to make life as easy for them as possible because they're not too smart. Or at least we don't think they are. Or maybe we're not too smart because we think they're not too smart. And so this workflow process, where we uploaded 70,000 documents over a 2 to 3 week period, each sale generates between 5 and 10 documents. The sales rep, as part of his process, needs to upload that into Salesforce.com. So we looked at the native functionality that came out of the box, and it required multiple clicks. And I'm sure all you know that users and clicks don't go together. That was too many clicks. Well, how many clicks do you want? We don't want to click any. Well, you got to click something. Well, none. So it was, an annoying experience, as my colleagues will tell you. So what we had to do was extend the front end for Salesforce.com and build some kind of mechanism that would allow them to upload multiple files with the minimum amount of clicks. So the choices that we had on hand were using Flex or an ActiveX control. We opted for Flex as the multiple file upload mechanism. We made this choice because it was lightweight. We felt that our total cost of ownership would be lighter with Flex, with the way we could distribute it to the desktops. It's really part of the application. You just need to have, Flash as part of your browser. but also because of the technology alignment. Not only with us, but with Salesforce.com. We have a significant investment in Flex on some of our some of our online applications used by the electronic side of the business, but also Salesforce.com, as you can tell by the other sessions that we've seen over the past few days, has embraced that fairly significantly. So we saw there was a tight, a good decision would be to follow Flex for those correlations. Now, integration. Now I want to thank my new friend over here, because we hadn't met each other until a few weeks ago when we were doing our demonstrations, where we were going over our presentations together. And he brought up the heartbeat pattern. And I said, hey, we're doing that too. And I said, this is, it made me really happy to see the heartbeat pattern. His is probably a little bit more elaborate than the way we're doing it, but it just shows you that there are common solutions out there for common problems, and if you look hard enough, you will come to an optimal solution. And the fact that we're doing something similar, gave me a real warm fuzzy, knowing that we're approaching this the right way. As in that application where you have the Salesforce.com needing to communicate with an external application, what we're doing is we're taking those documents out of Salesforce and moving them up into the document management system. That process of indexing the documents is fairly heavy. Not only are the documents that need to be transferred over the wire, and we have absolutely no control over the size of these documents. They could be 30 meg for all we know, since sales reps kind of do bizarre things. And once it does get into the document management system, there's another mechanization that takes over and another workflow that's sitting up there and sitting down there in our ecosystem. So it could take up to 5 minutes for a sales rep, all of a sales documents to be finally indexed in our document management system. So our implementation of the heartbeat pattern is to use a future call, and what we do when the account management person is done with their approval process, they click the button and we send out a little heartbeat to our document management system and say, hey, I have work for you. That document management system takes over and utilizes the API of Salesforce.com as an external client and does all of his work. So it becomes a completely asynchronous process out of the hands of the client, out of the hands of Salesforce.com from a client perspective. Now, there's a lot more complexity in that, where we had to really jump through hoops to put together an exception framework and a security model to support all of this. But the heartbeat pattern was the basis for this, and I think led us into developing what is, I think, is a pretty clever solution. Next is evolving complexity, and this being the advanced developer stream, I don't think this will be news to anyone in this room. We had an application, I'm going to just call it the customer summary, and it started off as this initial simple one-page, free-form text. And it was all configuration driven. We were able to put it together just by doing clicks and dragging, dropping, what have you. It was no real coding. And we showed it to the users, and they said, it is good. Give us more. So we did a second evolution of this project, where we started utilizing multiple pick lists and links to other objects and all other sorts of doodads to make life a little bit easier for them. And we showed it to them, and they said, it is good, but give us even more. We want dynamic pick lists. We want real-time integration with the enterprise. At that point, the direction we were going with configuration-driven design really didn't support this model. So what we did is we switched from using that to doing visual force and custom controllers. Now, the question that I wrestled with a while as we were going through this process is, if I knew way up front during evolution number 1 what the final state would be, would I have gone with configuration-driven development or started off immediately with visual force and custom controllers? And I think we made the right decision. And even if I knew it up front, I probably still would have gone that way. I think that the return on investment and the time to market that we accomplished up front with the configuration-driven design and development, giving the users the ability to use this sooner, more than made up for the minor rework that we had to do at the tail end of the project. Okay, before I get into the integration design patterns, I just want to show you our ecosystem again. Up on top, we have Salesforce.com, Salesforce.com communicates with our legacy applications through our enterprise service bus. The enterprise service bus then talks to functionality that's been deployed as web services within our legacy applications. Now, we have more of a, we have been striving to build a true service-oriented architecture. And, you know, service-oriented architecture, if you follow David Lincecum, is something that you do, not something you buy. So that was a significant project in and of its own. So with this, we needed to develop a versioning, security, and everything else that goes with a SOA. We really wanted to have much more than just a point-to-point application. So we have 3 different ways that we integrated between Salesforce.com and our legacy applications. I know I just spoke about the SOA, but the first strategy that we followed and that we still use significantly, even though our SOA has matured over time, is simply using data warehousing techniques. We have a huge investment in Informatica that we use to support our internal data warehouse. And when we started working in the cloud, we wanted to leverage this existing relationship and the existing processes that we have already set up. So we purchased the plugin for Informatica that communicates with Salesforce.com and just really merged these new processes into our existing batch cycles. And it was really the same people who maintained the Informatica ETL process for our data warehouse are actually the same ones who are doing the work for the integration with Salesforce.com. We found out that this approach of using ETL and massive data movement works well when real time is not critical, when you can rely on periodic updates to Salesforce.com. You're relying on a batch cycle. We have a 24-hour batch cycle, so primarily we're updating Salesforce.com once a day with this type of data. And we're using this for when the data can be up to 24 hours old. We also found out this works when performance is critical, where it's better to have the data closer to the user than to have to suffer through any of the overhead that comes with the service-oriented architecture. And we also found this to be helpful when the data or the process is owned within Salesforce.com. Like I said before, we're going through our legacy applications, we're looking for commonalities, and we're moving those commonalities out into the cloud. If that data is supporting that functionality that's deployed out in the cloud, then that data is best placed out in the cloud with that functionality. Things to look out for is avoid denormalized data if possible. And I should probably have just taken off if possible and avoid and said do not use denormalized data. It's really just a simple data processing fundamental. If you're working with denormalized data, what could be normally a change to 1 row is a change to millions. And out in the cloud, it just makes this, magnifies, you know, that dilemma, 1,000-fold. And also realize that mistakes can be costly. Take your time, use sandboxes, make sure that you're doing what you think you're doing, that it's all going to work, because mistakes can be costly. If you spend a weekend moving up 11 million records, and you found out you made a mistake, it's going to take you another weekend to fix it. So if you take it in chunks or do a dry run in a full sandbox and review your results, you will thank yourself, because you could really make a mess. Isn't that right, Tia? Okay. Our other type of integration is our service-oriented architecture. That goes back to that other slide that I had showed you with the enterprise service bus and the legacy applications deployed as web services. We found out this approach works when real-time connection to the enterprise ecosystem is critical, where the data doesn't belong up in Salesforce.com for whatever reason, but you need access to up to the second valid data. And also when the data or the process is owned by the legacy application. As I said before, our legacy applications are being rusted away to becoming pure fulfillment engines, simply our ERP. So the orders are going to be processed in the ERP. So and we also want that to happen with relative speed. So it's a service-oriented architecture that takes this information and inserts it immediately in real time into the fulfillment engines. Tips while working with this space is try to avoid as much chatter as possible with your service-oriented architecture. Really use it in conjunction with data warehousing. If you're creating drop-downs and pick lists, you could use a web service to go get that data and create that pick list and all of that. But what you're doing is you're creating this really unnecessary chatter, putting a lot of overhead on your SOA, on your ESB, and what have you. That data is best left being maintained through some sort of ETL process or manual if you have the stomach for it. And realize that when you're building this out, strive to do more than just point-to-point application, but create a whole service-oriented architecture. And with that comes the SOA governance, security, and firewalls that go along with just the topology of the network. So this alone is a significant project all by itself, and somebody could really make a mess out of this. And we're doing as much due diligence as we can on the governance point to avoid that, and I think we're doing a pretty good job. We're using Mule as our ESB, deployed on JBoss, and we're using Mule Galaxy, which has just become part of the standard product to support versioning and security and things like that. Now, the third integration point, we call it application integration. This is another thing that we stumbled on early in the process that I was a little unsure about at first. And this is when we're simply exposing a separate application within a Force.com window. The actual user, the client to the application, thinks they're working in Salesforce.com, but they're actually functioning in another environment. We found out that this worked when we have real-time functionality required, but the functionality is best hosted elsewhere. And our implementation of this is, just to give an example, is we took Java Server Faces has some grid functionality, which allows you to create these nice grids and sort them dynamically and do all these really cool things with us. And we needed to be able to have, in some cases, hundreds, if not thousands, of data in this grid at a particular time. Really couldn't have been supported by the ETL process because of the constraints there, and it really didn't fit into the SOA model communicating with Salesforce.com due to some governance limitations. So what we did is, using Java Server Faces, created a grid application, made it really as dumb as possible and completely parameter-driven, and we insert that as an iframe within a Force.com page. So the user has what's really JSF functionality, the ability to dynamically sort and search through grids, but within a Force.com window, and it's really given us the best of both worlds. And then I found out, just by going to different users group meetings, and that a lot of other applications follow that very same design pattern where it's data that's actually replicated in another application, but to the actual end user perspective, it's one application. The tip that I have to give with this is what you're doing is you're creating a very complex ecosystem with some significantly strong dependencies. So if there's a problem there, it could be in any number of places. There may be some need for data replication. So it's something to be careful when you're implementing it, but don't be respect this design pattern. Don't be afraid to implement it, but make sure you're doing it correctly because it is adding a level of complexity into your environment. And so in conclusion, first thing is configure before you build. Let Force.com do the work. Second is don't be afraid to collaborate with the enterprise. Not everything belongs up in the cloud. It may be best kept in the ecosystem, in your internal ecosystem. However, some things what we're doing is our first choice is to put it in the cloud. If it doesn't fit, we build it in the ecosystem and using our 3 points of collaboration. Third, it's still computer science. And I found this with a lot of the contractors that we've had working in our environment. They seem to neglect a lot of the data processing principles. And we'll be doing code reviews, and I'll say, hey, look, you're accessing a null variable of a value without checking for a null condition. I said, you'll get a null pointer exception. It's going to cascade through this call stack, and it's going to take you 2 weeks to figure out where it is. And I'll get an answer like, well, this is, cloud computing. We do things different. And I'll be saying, no, I wanted to see more try-catch blocks. And they'll say, well, time to market is what really matters. And I say, no, it's all data processing. There's a way to do it. Do your designs up front. I'm not saying don't do prototypes. don't do iterative development, but design it out. Make sure things are going to work together before you actually start building it. Use design patterns. Use the DAO pattern. I mean, Salesforce.com is already built on Model View Controller. Utilize things like that. We're following a strategy where we're asking all of our developers to take all their SOCL query and utilize the data access object pattern to eliminate clutter in our business objects, and so all the SOCL query is all co-located in unique classes that we can take advantage of reuse and things like that. And again, iterate. And fourth is create your own social network. Meet friends out in the Salesforce.com and the cloud world. If you're doing something new and interesting, call up these new friends, ask them what they're doing, what do they think, and take advantage of each other. Okay, thank you. Okay, yep. Okay, are there any questions?
In the background?
That's one of the things we struggled with. We found this model is implying it isn't implying that. In some situations, we couldn't go truly normalized. But if we have 11 million records and 5 million of those have an office name, and that office name changes, it's much easier to change that in a reference table and let it cascade through the relationship back to the primary table. But there were circumstances where that just didn't work. So, as with any standard, it's a default rule, and let the conditions dictate otherwise. So, yeah, we do have denormalized data in there when necessary, and it really makes me very, very nervous. But following the normalization, the fifth normal form, what have you, it does, in the long run, I think would make things much easier. Maybe when you get into reporting, and it will limit some of your ability to do custom reporting, and if that, not custom reporting, but do out-of-the-box reporting with these multiple different relationships, if that becomes an issue, then back off on the denormalization, back off on the normalization. So it's all a give and take, and something you need to look at, but try to avoid it. At least from our perspective, we've found out that it's much easier to avoid it, but there are circumstances that push you in a different direction. Yep. Yeah, what happens is they're up in Salesforce. The workflow process is all within Salesforce. When the final approval button is clicked, I'm done, these documents are done, the process is over. A future call, a web service call is made up to the document management system and says these documents are ready to be indexed. That document management system then utilizes the Salesforce.com API to pull the documents out one by one and index them in the document management system. Okay, why don't I just channel it through Salesforce directly into the document management system? So when they click the approval button, then call a web service that moves the whole document up as one. We found that the problem that we were having then was, well, there are a few reasons why we did that. One, it was we weren't really sure of the size of the documents, and we were worried about governor limitations and waiting for the response of the web service. I know you can do a future call and all of that, but another thing that drove us to it was really just an isolation and a delineation of responsibilities. I wanted to be able to have in this middleware application that is the bridge between Salesforce and the document management system that's doing all the work, be able to isolate all that functionality in one particular place. And then if later we find out that this asynchronous process doesn't work, we could take it and make it a batch process and apply some controls that way. SOA issues? Oh, okay. With SOA, you mean just from a pure service-oriented architecture perspective and not a Salesforce.com perspective? Oh, in general, probably the biggest one is really the adopting single ways of doing things. Each person had their own idea of what a customer is. Each person had their own idea of what an order is, what a sale is. We wanted to develop a service that is place order. People, their idea of an order would be something different. It was also the delineation of functionality, what should be a web service and what should be up in Salesforce.com. Even though we did have a strategy, it was open for, there was quite a bit of wailing and gnashing of teeth. I would say the biggest problem we had if you get beyond the philosophy of service-oriented architecture and something you do versus something you buy and normalization and standardization, was that we have 3 different teams working on this, folks who were developing the enterprise service bus and the people who were working in each of the legacy applications of developing their services. So there was functionality that we needed to aggregate the results from both legacy applications in the enterprise service bus, returning it to Salesforce.com. And you could never imagine how many people the arguments that people could make to say that the people who were developing the web services felt that this certain functionality, certain aggregation functionality belonged up in the enterprise service bus. The enterprise service bus folks would be saying, well, you know, we're developing functionality out here in the abstraction layer that belongs much better in the legacy application layer. So there was a lot of give and take back and forth towards that. But I would say the biggest issue with any service-oriented architecture, from at least what I can tell, is this normalizing and standardization on what these different processes are and what the new model you're going to follow. So I'd say it's more of a business problem than a technical issue. As far as technical issues, the configuration of the web services for stress testing, timeouts. The ESB is on JBoss. One legacy application is on PeopleSoft. Another one is on a more proprietary Amdocs application. We're trying to standardize on SOAP frameworks, and so choosing CFX over Access 2, things like that. So there were technical hurdles that we had to overcome. Versioning is something that we're very early in the whole versioning process, so I think we have more problems to stumble on then. And security, the issue was simply just defining what a security model was going to be, and we're going to be using the Spring framework to actually implement that in the ESB. So. Yes, yeah. We did a lot. We've done a lot of customization.
Okay.
Yeah.
I think in the attachment object you can't add a custom field, right?
Right. In fact, our attachments, we actually have a custom attachment object. Okay. It's that workflow application. The actual workflow itself is out of the box. It's extended for its flexibility, but we have a significant investment in custom objects for those attachments. We have a concept of a document, which is not really the other kind of document. It's like an object-oriented document that the document is attached to, and that's attached to a package. And each one of those levels within the object map has its own behaviors and attributes, and we use them throughout as indicators throughout the workflow process.
Did you use naming conventions, or were you dependent on the user to select something so that they uploaded a certain kind
Yes, yeah, we did. Yeah, that was funny that you say that. That was a bone of contention at one point, was how do we, if the user uploads a document, how do we assign the different attributes to that document? We know what it is. The users wanted us to be able to go in there and read a Word document and figure out and say, oh, if the third line has this word in it, that means it's this type of document. And we're saying, well, we may be kind of smart, but we're definitely not that smart. So we eventually had to standardize on, as documents uploaded, the user needs to select the different attributes. Thanks. It's, you guys know the specifics on what we're getting with Informatica? It's It's not as fast as if you were doing bulk queries and, when we were doing uploading from one database to another where the endpoint is another database. The Informatica plugin for Salesforce.com is simply is a web service client. And I'd say several hundred per minute. I'm just not sure. Okay, yes?
Just now, you just mentioned the transaction in the Apex code, and I'm wondering that I expose the Apex method to web services,
I'm sorry, I can't really hear you. Is the microphone on down there?
Yeah, would you mind using the microphone?
Thanks.
Jeff mentioned the transactions in the Apex code, so I'm wondering if I expose the Apex method to web services and some external partner or system will consume the web services, will Salesforce still handle this transaction, or I should handle it in the external application?
Okay, we're relying on Salesforce. We're not doing anything special. If we're calling if we have an outside client that calls an Apex class exposed as a web service, we're letting Salesforce.com, Force.com platform handle all of that. We haven't come into a situation that required us to do anything else, but as default, we're not doing anything special when we call a web service, and as far as that goes.
Yeah, and in general, I think you want to do much of the transactions inside of Salesforce that deal with Salesforce data as possible, because you really don't have an option of rolling back changes in Salesforce. Mm-hmm. You can kind of revert, but still, that last modified keeps getting, updated. So if it's dealing with Salesforce data, that's the place where you should probably think to put your transactions in.
Okay. Yeah.
Thank you. Yep. Sure. Yes. Yep. We found it the hard way. I believe that's how it's being done. I think it's being done. If it's okay. When we're doing bulk uploads via ETL, are we turning off the triggers and validation? And the answer is yes, we are. Oh, yes, when we do massive big uploads, like 11 million records, those times, yes, we do. When it's just a normal daily run where it's a much limited size, no, unless there's an optimization problem, then they're turned off. I don't believe we're doing it programmatically. I think when we do it, it's a big deal. It's something that we've encountered a problem and we're working around it. Okay, anybody else? Hi, Jacob. Is that you? Oh, sorry, I thought we met before. Okay.
Okay. Well, thanks a lot, Rick.
Thank you.
So thanks a lot, you guys. I hope you enjoyed the real-world samples. These are guys that are wrestling with problems that you guys are wrestling with all the time. And I think it's kind of nice to see what other people are doing and struggling with and finding ways, solutions for those. That's the end of this session. I just want to thank everybody for coming, and we'll see you next year at Dreamforce.